You're welcome. This is solutions to NMC mathematics Olympiad question for junior categories. So I'm going to start with the first question. Number one, how many numbers 1, 2, 3, 4 up to 2009 are neither divisible by 3 nor 5? You can see these questions. It's not saying how many are divisible by 3 or and 5, but it's saying that how many are not divisible, neither divisible by 3 nor 5. So it means we need to first find those ones that are divisible by 3 and then those ones that are divisible by 5, and both 3 and 5. So after getting that one, then we also need to what? So okay, what I'm trying to say here is that what we just need to do, those ones that are divisible by either 3 or 5, so get them first. So when you get those ones, you may now what? Remove them from 2009. Now, how do we do that? There is a concept of Venn diagram. Let me just quickly do a kind of analysis of that for you. Now, if you have a circle like this, for example, you have a circle, we have this. These are numbers that are divisible by 3, and these are numbers that are divisible by 5. So this is the space for them. So the middle one is those numbers that are divisible by 3 and by 5. So in that case now, what we just have to do, those ones divisible by 3 and 5, an example of that is 15. Because by the time I'm counting numbers divisible by 3, I'm going to count 15. By the time I'm also counting numbers divisible by 5, I'm going to count 15. So it will be like I'm counting that twice. So in order to remove counting multiple number of counting, so there is need for us to use this principle of Venn diagram. So what I just have to do is I need to get to know the numbers that are divisible by 3 or 5. I need to know the numbers divisible by 3, add them to numbers divisible by 5, then you remove numbers divisible by both 3 and 5, like 15. Numbers divisible by 3 and 5, so you remove that from it. So how do we go about that? Now, how do I know how many numbers are divisible by 3 in the whole of this sequence 1 to 2009? What I just need to do is to get that, I will divide 2009 by 3. When you divide 2009 by 3, we get 669. That's 669. 669. I mean the integer part. I don't need the decimal part. Numbers divisible by 5. Numbers divisible by 5. To do that, 2009 divided by 5. When you do that, we have 401 as the integer part. That's what I need. Then I also need to know those ones that are divisible by 3 and 5. Any number divisible by 3 and 5 must be divisible by 15. That's 3 times 5. So divide 2009 divided by 15. So that is number divisible by 15. Okay? So if you divide that, you get 133 as the integer part. So using this particular formula, I'm going to have those numbers that are divisible by either 3 or 5 will be 669 plus 401 minus 133. So 133 repetition, so you need to remove that. So if you remove that, we are going to have 937. And from there, so it means 937 are the numbers that are divisible by 3 or 5. Now, so to get those ones that are neither divisible by 3 nor 5, it means I need to subtract 2009 minus 937. 2009 minus 937 will give us what? 1, that is 1072. 1072. So the answer is G. Okay? So the next question, we have this. A plus 1 over BC equals 1 over 5. B plus 1 over AC equals minus 1 over 15. Likewise this. So we want to find the value of the quotient C minus B divided by C minus A. Okay? So now, how do I get C minus B here? I can get C minus B by using this minus this. Okay? Let's quickly do that. Let's do that. Okay? C minus, let me say this, C plus AB, C plus 1 over AB minus that of B. So I'm going to have, that's B minus, it's a common minus, so I try to expand directly. So it means that will also be the same thing as 1 over 3 minus 1 over 15. Okay? So doing that, I'm going to have C minus B, I will see it there, then plus 1 over AB, 1 over AB minus 1 over AC. Okay? So, and then that will be 1 over 3 plus 1 over 15. 1 over 3 plus 1 over 15. Can you work out 1 over 3 plus 1 over 15? So that should give us 6 over 15. 6 over 15, which is same thing as 2 over 5. So that should give us 2 over 15, sorry. 2, yeah. So 3, 6 over 15, 3 here 2, 3 here 5, so 2 over 5. So that will give us 2 over 5. So if that is giving us 2 over 5, okay. So then another thing is that this is C minus B. I can also try to find the LCM here. Find the LCM. So if you find the LCM, we have ABC. And so here we are going to have SBC. Okay. So we have C minus B. Yes. C minus B. Okay. So I hope I'm correct there. If 1 over 3 plus 1 over 15, that's 5, that's 6 over 15. Yeah, I think that's correct. Okay, so that will give us 2 over 5. Now in this case, what you can just do is that C minus B is common. C minus B, bring it. Then we have 1 plus 1 over BC. 1 plus 1 over ABC, sorry. So that will give us 2 over 5. So that's that. Okay? So I've been able to get C minus B. I think I can do the same thing so that I will get, let me clean this area. Okay? So to do the same thing, I should be able to get, yeah. So in this case, to get the denominator C minus A, so let me subtract that of C. I have C plus AB, C plus 1 over C plus 1 over AB minus A minus 1 over BC. Okay? So that will be 1 over 3 minus 1 over 5. 1 over 3 minus 1 over 5. So that is C minus A will come out. If you find the LCM there, We have A, B, C. Okay, so that will be what? C minus A equals 1 over 3 minus 1 over 5 will give us 2 over, that will give us 2 over 15. 2 over 15. 2 over 15. Okay, so 2 over 15. All right, so getting that, and then C minus A is common, bring it out. I have 1 plus 1 over ABC, and that will give us 2 over 15. Okay, so you can now divide what we have in equation 1. If you call this one equation 1, divide it by what we have in equation 2, call this one equation 2. So we can see that this one, we cancel out this. Then at the end of the day, we have C minus B over C minus A equals 2 over 5 divided by, that is times 15 over 2. Okay, so this cancel this, 5 here 1, 5 here 3. So it means the solution to that is 3. Okay, so the next question, it said determine the product of the root of 50x raised power 50 plus 49x raised power 49 plus, and so on up to plus x plus 1 equals to 0. Now there's a concept here that we need to look at. That's the concept of from symmetric property of quadratic equation. Now I think this is junior class, but notwithstanding, let me just explain some things for you here. By the time I explain that, I think you should get that concept. What we do there is now, at least you must have heard of quadratic equation before. So when you have a quadratic equation, it means we have equation of, for example, we can have ax squared plus bx plus c equal to 0. So in that case, we have root. The product of the root there will just be c over a. C, the one without x, divided by a. So in that case, we say if alpha and beta are the root of this equation, if alpha and beta are the root of the equation, then the product, which is alpha multiplied by beta, usually give us c over a. Okay, so from there they now expanded that concept. So we can have, if we have so many polynomials of higher degrees, the general form of the general name for quadratic equation is polynomial equation or polynomial function. So when you have power 3, power 4, power 5, power 6, so all of them generally we refer to them as being polynomials. All right. So for the product, if you have 3, okay, let me also try the example of 3. If you have ax raised power 3 plus bx squared plus cx plus d equal to 0, plus d equals to 0. Okay, so if you have this, for example, the product, if it is alpha, beta and gamma, the product which is alpha, beta and gamma will be minus d over a. Exactly, the last one here is d. But why am I using minus? Because you also swap the sign. For a, I'm going to use plus. For b, it is minus. For c, it is plus. But here, let's swap it. For a, it is still plus. For b, when you are using it, you attach minus. For c, it is plus. For d, it is minus. You can get it? So it means if it is alpha, beta, gamma, it will be what? Minus d over a. So it means generally when we have the highest degree to be even, the product will still be what? Plus. When we have the highest degree to be what? Odd, like 3, the product will be what? Minus. So that is it. So it means when we talk about ax4 now, we'll be having e over a as the product. When we have ax5, we'll be having what? Minus f. So now what do we have? We have raised power 50. It means it is what? Even. So it means the product will be plus. So finally, as a result, the product of the root will be what? 1 over 50. 1 over 50, the first number. So this is the answer to that one. Now, so I'm going to question 5 now. For question 5, let's see what we have there. I can't write outside the board. I think writing outside the board is trying to create a problem. Okay, so I need to clean whatever I've written immediately. So okay, so now for the next question, question number 5, s cubed plus 2s squared plus 3x plus 4 equals 0. A, b and c are the roots. So find a squared plus b squared plus c squared. Now, one thing we need to know is that if by the time we square this, we have this expansion, a plus b plus c. Expand it. When you expand it, I think your teacher should be able to guide you on the expansion of this. So a plus b plus c. When you expand this, it should give us a squared plus b squared plus c squared plus 2 ab plus bc plus that will be 2 ab. Okay, so that will be 2 ab. Yeah, so that's what we'll get when you expand that. Okay, so expanding that now, you can just try it. Okay, sorry, I think it's going to give us 2ab plus bc, okay, plus that's 2ab plus 2 into bracket ab plus bc plus ac. Yes, ac. Okay, so but we need a squared plus b squared plus c squared. So bring it out, make this the set of the formula. Your teacher should be able to guide you better there. So we have a squared plus b squared plus c squared to be equals to a plus b plus c all squared minus 2ab plus bc plus ac. Now, okay, let me explain. I need to explain some things. I was explaining number 3 the other time. So you see, this is power 3 now, like I said. So in this case now, this is, we can get the sum of the roots here. Sum of the roots will be what? A plus b plus c, and the answer to that will be what? 2, that is the square root of s squared, the coefficient of s squared over the coefficient of s cubed. Is that clear? So what we are going to do, so a plus, that's the sum of roots. Our sum of roots will be this, that is the coefficient of s squared over the coefficient of s cubed. Then the sum of 2, like we have ab plus bc. You see, this is like sum of 2 roots, or sum of the product of 2. Yeah, sum of the product of 2. Sum of the product of 2. So then the last one will be what? The product of 3. I hope you get that right. Let me repeat myself again. Now, when you have, this is a polynomial of degree 3. So a polynomial of degree 2, for degree 2, that's ax squared plus bx plus c equal to 0. The sum of the roots will be minus b over a. Why the product of the root will be what? C over a. But the time we get polynomial of degree 3. That's ax3 plus bx squared plus cx plus d equal to 0. The sum of roots will be what? B. The sum will always be coefficient of x squared. So we also start from minus, this one will be plus, this one will be minus. So in this case now, the sum will be what? B over coefficient of x squared, that's minus b over a. Then the sum of product of 2, product of 2, you know we have 3 numbers now. Here we have just 2. That's why we have just product of 2. So in this case now, the sum of product of 2, we also consider it. And that will be what? C over a. And the product of the 3 will be what? Minus d over a. So that is what we are going to do now. So sum of the root will be what? Minus 2. So a plus b plus c will be what? Minus 2 over the coefficient of x cubed is 1, minus 2 over 1. And the product of 2, or the sum of the product of 2, yeah. So that is AB plus BC plus AC. That one will be that one will be plus 3 over 1, that is 3. And the last one, which is the product of all, that's ABC, will be equals to what? ABC will be equals to that's 4 over 1, that's minus 4. Okay, so let's substitute. Like I told you, if you expand this, you should get this: a square plus b square plus c square plus 2ab plus 2bc plus 2ac. So I factorize like this. So this is what we need to give us. So let's now substitute. A plus b plus c, square it, that's minus 2 squared, minus 2 multiplied by 3. So minus 2 squared will give us 4, minus 6. So 4 minus 6 will give us what? Minus 2. So the solution to that is minus 2. Okay? So the next question, I'm going to question 7 now. Question 7. Okay? So we jump some, maybe we'll solve that later. Okay? So all right, so for that one, now let's assume, I'm assuming that the square root of 7 plus 48, square root of 48. So they said, okay, the question said that express positive integers x and y such that we have this. Okay, that is it. So I'm using square root of a plus square root of b, where the square root of a is a perfect square. The square root of a will be a perfect square. That's why we are having it in form of x here. Now, if I square both sides, the square root will be removed here. So I have 7. I have 7 plus square root of 48. Now, if you should square this, we realize that we are going to have a plus 2 root ab, then plus b. So at the end of the day, it means we are having it as a plus b plus 2 root ab. Okay, which means that a plus b is 7, a plus b is 7, will give us 7. And I need to express square root of 48 in terms of root 2, in terms of 2 root ab. What I can just do is that I need to factor out 4 from that root 48. Root 48 is the same thing as 4 times 12. Square root of 4 is 2. So it means it will be 2 root 12. Exactly. So by the time I compare 2 root AB and 2 root 12, I will see that my AB, A times B is equals to 12. AB equals 12. Now I expect that students of junior category, some of you might not have done simultaneous equation, and even if you have done that, this involves a quadratic. So in that case, I will want to use the just substitution method here. So I can say that my A and B, I can use 4 and 3. One will be 4 and one will be 3. So if A is 4, B is 3. When you add them, you get 7. If you multiply them, you get 12. So as a result, my final answer will be square root of A, which is square root of 4, plus square root of 3. So square root of 4 is 2. That's 2 plus root 3. Okay, so that's the answer to that, 2 plus root 3. The next question, we have given that A plus 1 over A equals 3. Find the value of A for A raised power 4 plus 1 over 4. Okay, I will also quickly cancel this out. Okay, so how do we do that? Now for that one, before I go to A raised power 4 plus 1 over A raised power 4, let me try A raised power 2 or A plus 1 over A. If I square it, your teacher should help out in the expansion. Expansion of this will give us A squared plus 2 plus 1 over B squared. 1 over B squared. Okay, so sorry, 1 over A squared. Now I need just A squared and 1 over A squared, so that 2 will be taken to the other side. From there I'm going to have A plus 1 over A, everything squared, minus 2 will give us the value of A squared plus 1 over A squared. Okay, so looking at that, from there I can get the value of A squared plus 1. So look at A plus 1 over A. A plus 1 over A has been given as that's 3. So I have 3 squared minus 2 will give me the value of A squared plus 1 over A squared. So that's 3 squared is 9. 9 minus 2 is 7. So meaning that A squared plus 1 over A squared is what? 7. Okay, keep that value. Now I want to find the value of A raised power 4 plus 1 over A raised power 4. A raised power 4 plus 1 over A raised power 4. Now let me break it down. A raised power 4 is same thing as A raised power 2, everything squared, plus 1 over A raised power 2, everything squared. Is that clear? So what I'm going to do now is that I'm going to assume that A is representing my A squared. Look at the same way I did for this. Look at this. Look at this formula. I can rewrite it and say that A squared or B squared plus 1 over B squared is same thing as B plus 1 over B, everything squared, yes, minus 2. Yes, I can rewrite it. So now I'm now assuming that A squared here is representing my B. Is that clear? So if I have A squared squared plus 1 over A squared squared, it means it will give me A squared plus 1 over A squared, everything squared, minus 2. I hope you get that. So this is like A squared squared, just like B squared. So I'm treating A squared as a number, just like B here. B squared plus 1 over B squared. Is that clear? So which will give me B plus 1 over B, everything squared, minus 2. The same thing here. If I have it for 1 over A squared squared plus 1 over A squared squared, It means it will be what? A squared plus 1 over a squared, everything squared minus 2. Alright, but I've got the value of a squared plus 1 over a squared to be 7. So that will be 7 squared minus 2. 7 squared is 49. 49 minus 2 will give 47. So that's the answer, 47. Okay? So, the next one, determine the remainder when 2x raised power 4 minus 3x cubed plus s squared plus x minus 2 is divided by s squared minus 3x plus 2. Actually, I have tried to see how I can simplify this, especially for our students in the junior category. But I have not been able to see that. But let's see. I think you should be able to understand the concept of division, long division. Since you all did long division in primary school, or possibly in, in primary school. So, in such a case, let's see how the long division will do. Now, let me take us back to long division. We want to divide 11 by 2. 11 divided by 2. What do? We go to long division in primary school. 2 will be outside, 11 will be inside. What do? Say 2 in 11 will give us what? 5. So we have divided. Then you now multiply. 2 times 5 is 10. So we have what? Multiplied. After multiplication, we also say what? We subtract. 11 minus 10, that's 1. So it means the remainder is 1. Okay? So we can now apply that concept for large numbers. For example, you want to do 213 divided by 5. So 213 divided by 5. 5 in 20 is what? 4. 4 times 5, 20. Then you subtract 1. You now bring 3 down. 5 in 13 again. It will give us 2. So 2 times 5, 10. And then you subtract. So you can see we are dividing, multiplying, subtracting, dividing, multiplication, and so on like that. So that's what we are doing. The same principle, we apply it here. Now let's say I want to apply it for this question. So I have 2x raised power 4. 2x raised power 4. Okay. Minus 3x raised power 3 plus s squared plus x minus 2. Okay, minus 2. So and outside here we have x raised power 3 or x raised power 2 minus 3x plus 2. Okay, so let's divide. Now how you be dividing here? If you want to divide, you pick the highest value, the highest power here and the highest power here. The highest power here is 2x raised power 4. 2x raised power 4 divided by x raised power 2. Okay, so if you divide by x raised power 2 from what you have done in standard form, so this one will just be x raised power 4 minus 2. So that will be x raised power 2. So x raised power 2 here, x raised power, it will give us x raised power 2. So that's 2x raised power 2, the answer. So put it on top here, 2x raised power 2. Now use it to multiply. Use it to multiply. 2s squared multiplied by s squared. It will give us 2x4. 2s squared multiplied by 3x. 2 times 3 will give us 6. X times s will give us s squared, s cubed. Or x times s squared will give us s cubed. So that will give us minus 6 s cubed. Okay? Now the next one, 2s squared multiplied by 2. It will give us 4s squared plus 4s squared. So you can now subtract. If you subtract 2x4, we cancel 2x4. So we are left with minus s cubed, minus 3s cubed, minus, we are subtracting. So what you just need to do is bring out the numbers. So we have minus 3, minus 6. That will be minus 3 plus 6. And that will give us what? 3. So that's 3s squared, s cubed. Okay? So s squared minus 4s squared. I've told you bring out the coefficient. So the coefficient here is like 1. So 1 minus 4. 1 minus 4 will give us minus 3. So we have minus 3x squared. Then bring out those remaining one left. We have plus x minus 2. Plus x minus 2 minus 2. Okay? So we also divide again, just like we did in the case of 2 and 3 here, until we get something that the remainder that can't divide again. Now, so 3x cubed divided by the highest here is s squared. So s squared will subtract. So 3 minus 2 give us 1. So we have 3x. So that is plus 3x. So if you multiply 3x, you multiply s squared, it will give us 3x raised power 3. 3x raised power 3. Okay? 3x multiplied by minus 3x, it will give us minus 9x squared. Minus 9x squared. Okay? 3x multiplied by 2 give us plus 6x. Okay? So this cancel this. So bring out the coefficients. Minus 3 minus 9. That will be minus 3 plus 9. And that will give us 6. So that's 6s squared. Do the same thing for this. 1 minus 6. 1 minus 6 gives us minus 5x. Then bring out the minus 2. Minus 2. Okay? So divide again. 6s squared divided by s squared to give us plus 6. That's 6s squared divided by the s squared that is outside here. So that's 6. So use 6 to multiply. 6 multiplied by s squared to give us 6s squared. 6 multiplied by minus 3 to give us minus 18x. Okay? 6 multiplied by 2 will give us plus 12. Plus 12. Okay? So subtract. If you subtract there, I've told you bring out the coefficient. So minus 5 minus what? Minus 18. So minus 5 plus 18. It will give us 13. So we have 13x. Then minus 12. Minus what? Another 12. That's minus 14. So this is the remainder by the time you divide. So which is 13s minus 4. That's D. So that's the solution to that one. Now the next question. Given that 3x squared plus x is equals to 1, find the value of 3s squared, 3s cubed minus s squared. Okay? So how do we do that? Let me clean this. Okay. So for this, all right, for this one, let's see what do we have. 3s squared. Okay, so they have given us the value of 3s squared plus x is equals to 1. Now we just see how we can simplify this. We have 6s cubed minus s squared. Okay, minus 3x so minus 3x plus 20. Okay, so now we need to manipulate here. Actually what we need is 3x squared plus x. I'm sure that by the time I bring out 2 here, if I divide this one by 2, I'm going to have that 3. I will have that 3s squared. I will have, or if I divide this one by 2x, I'm going to have, yes, I'm going to have that. So what I can do is that we just need to manipulate. I have something that will make this, that will make it to be factorizable. What I'm trying to say is that by the time I bring out 2x here, if I bring out 2x here, so I should be able to bring out, so okay, meaning that I need to bring out 2x here. If I divide, that's 2x, then I'm going to have 3x squared. Is that clear? 3x squared. So to be able to get something like I need x. Yeah, to be able to get something like x, it means I have to add to this equation 2x squared. Yeah, and I also subtract 2x squared to balance up. So what I do is 6x cubed plus 2x squared, also minus 2x squared. So it's as if I have not done anything. Then come back to all the what you have there. Minus x squared minus 3x plus 2020 plus 2020. Okay, so what is common here? 2x, just bring out 2x. We are left with what? 3x squared. Yes. Then if you divide this one 2 by 2x, you have plus x. Then this one, bring them together, that will give us minus 3x squared plus 3x plus 2020. Okay, so 3x squared plus x is 1. So if I put 1 here, it means I'm going to have 2x minus 3x squared plus 3x plus 2020. Okay, so 2x plus 3x. Sorry. Okay. Yeah. So this is 2x. So I have 2x here because I've substituted 1. Okay. So I'm going to have 2x. Oh, sorry. This is minus here. All right. Okay. This is minus 3x. So now 2x minus 3x will give us minus x. So I have minus 3x squared minus x plus 2020. Now minus is common here. Bring out the minus into bracket 3x squared plus x, close the bracket, plus 2020. So 3x squared plus x is 1. So I have minus 1 plus 2020. And that will give us what? 2019. We want to make okay, so that's the answer, 2019. We need to make the videos to be short. So because of time, I'm going to stop here for this. In the next edition, we are going to solve others. Thank you very much.